Okay, here's another problem. This time it's a two-step problem. We're going to use two different equations. We're going to use the relationship between energy, Planck's constant, and frequency. That's this one. Planck's constant is 6.626 times 10 to the negative 4 joule seconds. And we're also going to use our previous equation involving speed of light, wavelength, and frequency. Excuse me. So, you heat copper 2 chloride to 1200 degrees Celsius, and at this temperature it emits light with a wavelength of 450 nanometers. What is the energy of the photons at this wavelength? Alright, so if we're ultimately solving for energy, that means that we need to be using this equation. But the problem only gives us enough information to start out by using this one. So first of all, we have to calculate the frequency, right? Because we can't use this equation unless we know frequency. And the only way we can get frequency is from our first equation. Don't forget to convert nanometers to meters first, right? Because wavelength must be in meters. There's our frequency, 6.67 times 10 to the negative 14th hertz, or seconds inverse. Once we've got frequency, now we can plug in and solve for energy. Planck's constant is a constant. Excuse me, that shouldn't say wavelength, that should say h. There we go. Planck's constant is represented with h. So plug in Planck's constant, plug in our frequency that we just solved for. Our final answer is in joules because Planck's constant has joule seconds as the units, and our frequency is in seconds inverse. So seconds and seconds inverse cancel out. That gives me my final answer in joules.